my name is Manuel and Matthias. I come from Germany and I work as a software developer and software test automation engineer at a company in the north and west of Germany.
My name is Matthias Ratert. I'm also working for the same company, but I have a huge experience in software testing, working for Nokia, working for big companies like Visteon and Telecar, etc. And I have been working for a test consultant, but also as a test automation engineer and test manager. Our speech will be about soccer, about fun, about a lot of experience, about knowledge setup.
Yes.
Something more?
Much more.
And much more. With this opening videos. Welcome everybody.
Welcome everybody.
So, as mentioned, we are talking about soccer because we both are huge soccer fans. Our idea was to set up a soccer team today with you. So, is anybody here interested in setting up a soccer team and want to play with us? So we are volunteering to be the coaches. So anybody there is interested in soccer as well? Okay, I will be the coach, he will be the greenkeeper. So maybe then. Okay, let's start to set up the team. So I need at least 11. So if I just collect 1 or 2, it doesn't make sense to start. So nobody would start a soccer team with 1 or 2 persons. So you don't have to be good in the beginning. You just have to be able to kick the ball. You have to be interested in it, and you have to have fun to play soccer with us, but you don't have to be perfect. Because soccer shouldn't be a one-man show. So if you even have 1 good player, you won't win any games. So you should have all the 11 players on board right from the beginning on.
Yes. And the same applies to software test automation. You should not start with just 1 player and improve this player step by step. You have to have a team complete. Okay, you have to have the team complete right at the beginning. But there's huge difference between a soccer team. You won't have 11 friends. You have to identify and characterize each single player and his task, his role in our test automation team.
So, today we are collecting all the 11 players we have chosen for our team setup, and we want to present our team structure for our test automation project. So we have a goalkeeper, we have the defense, the midfield, and the attacking player. Maybe you cannot adapt it one-to-one in your project, but I think you get a lot of inspirations to set up your test automation project and to be successful within your area. As every soccer team, we need a sponsor, so to be successful. So our sponsor is Prognos Systems. This is a company we are working for. We are doing online monitoring and diagnostic systems for rotating equipment. And we are based in Germany. Even if we are wearing orange tricots, you might think they are from the Netherlands. And talking about soccer, what is this? No. We are not from the Netherlands, we are from Germany, and so we know about soccer.
Yes. Now let's take a look at each player of our team. And the first player of every team is a goalkeeper. And in terms of test automation, the goalkeeper is simplicity. It looks very simple when the well-known keeper Manuel Neuer catches a shot from Cristiano Ronaldo, but in fact it is a result of hard training and work. And being simple in test automation is a result of hard work too. Especially if you want to follow the advices we will give in this talk. Our first advice: implement only the parts you really need for your test automation, not more. Don't waste your time with creating a general purpose framework that everybody might use if this isn't your business strategy. It's too complex because several projects and companies have several requirements to automated testing. Then, I have to deep breathe. Then try to eliminate waste. As of a certain date, you have test specs, test implementation, and resources that you don't need anymore. Delete them. Things that you don't need anymore are just annoying while you're implementing, maintaining, and refactoring your test automation. And write readable scripts. Write your scripts first for readers and then for writers. Comment your scripts meaningfully, maybe with references to important parts to your test specification you're currently implementing with your test automation script. And to keep being simple in mind, remember Bruce Lee. He said, simplicity is the key to brilliance. I really like this slide because it is a perfect demonstration of what simplicity is. Does anybody know what this slide represents? Yes, it's a match schedule next year at Russia at the World Cup of the Netherlands. I'm just kidding.
So coming to the defense. So our first defense player are skillful people. So especially in automation, but in other areas as well. But in automation, it depends heavily. The result depends heavily on the people working for the test automation. So sometimes, as a player here, sometimes you have to do quite a lot of things in parallel. Sometimes you have to solve problems like the magic cube. And one advice I can give to the manager is to give the test automation engineers a long leash, to give them time to set up the right things in the correct way, and then you will have a setup which might be successful or is hopefully successful. And a visionary is sometimes useful to know where to go, to know where is the end goal, where is the final goal in the end, because the test automation is quite often a very long road to go. And finally, it's quite often good that you use people who know already the product you are testing. So from my experience on manual testers are very good candidates also to automate if you have an easy language to script, a keyword-based language to script, for example. So if you use manual tester and transferring the test cases you have already in mind to test scripts, that's really good advice, I think. The next defense player are good test subjects. So you should convince the software team that you are playing in the same team, so that they are also part of the soccer team you are playing in. And they should implement unit tests, they should make a lot of quality steps like static analysis, etc., to ensure that the outcome of the software is already good enough to use in the test automation. Otherwise, a lot of test runs will fail. Oops.
Okay, our next defense player is documentation and traceability. And as a trainer, as a coach of a soccer team has to document his tactical orientation, we as testers has to document our test cases and our test and test automation environment. At first, have a good test catalog overview. Order and categorize your test cases in a reasonable hierarchy. We at Prognos, for example, have 3 levels. Our first level are so-called test plans like UI tests. This test plan consists of several test suites. In the next level, for example, settings, and this settings test suite consists of several test cases related to the settings dialog. For example, change the UI language from German to English. It's very important that the structure of your test catalog is driven by the use cases, by the requirements you have, and not by the test management or test automation tool you use. Then try to document early as possible. Try to write the test specification before you implement it with an automation script, and focus on the what and not on the how, so that also other colleagues, maybe also non-technical colleagues, can understand your scripts, and ideally you review your specification with the stakeholders like the product manager. So hopefully you use a test management tool and not something like Excel or so. Excel is a good tool, but not for organizing hundreds or thousands of test cases you have if you do test automation. Whether or not, link your requirements, use cases, user stories, whatever you use for defining your functionality and very important bug tickets to your corresponding test cases. Report your results automatically. Our test automation sends status emails while the test runs, and archives the test results of a test run. Ideally, your test management tool supports persisting every result for each test case that has been executed. And while you do all these things, create knowledge. Describe best practices and standards for you and your colleagues, but do not hesitate to allow exceptions if necessary. So now let's deal with the last defense player. Abstraction is the last defensive player, and abstraction is great to welcome changes, and abstracting as much as possible ensures maintainability. You can see the soccer guys here. They built a tower, and each of the players defines its own layer in this tower while they are celebrating a goal. And using layer is great for abstracting things in test automation. And we at Prognost, we use keyword-based scripts for testing, and as a result, one layer is defined by the keywords the scripting language supports. And keywords are not only comments, but also, especially in context of automated UI tests, objects like windows and controls, hotkeys, menus, registry keys under the Windows platform, and very important, texts that are language dependent to support executing each test case under several languages, different languages. So it's a simple example here at the bottom. I think it's self-explaining what our test script, key-based test script does. It clicks a button, so the My App button, by moving the mouse to the position where the My App button is placed, and then presses the left mouse button to click it.
Okay, coming to the defensive midfield. So until now, I think quite all of the players are well known and maybe even used for in your project if you are doing test automation. The next player is quite controversial. So, and many people do not agree with us to implement this player, but we really believe in this player because it's really important from our point of view to have always a running environment and to be always up and running and ready for testing. So if there is a failure, of course you have to analyze, you have to report the bug to the software team, and quite often the software team takes a ticket, fixes it, and in the next test run the test cases hopefully pass again. But in real world, you create a ticket, you give it to the software team, but the software team is busy. The ticket is there for weeks, for months, maybe even forever. So nobody is solving this problem, and the test case keeps failing, keeps failing, keeps failing. If this is one test case, you will remember, if there are tens or even hundreds of test cases failing all the time, you will get blind and you will lose the fun for the test automation because you always have to remember, hey, this was this problem, this was that. So our practice is, if we think this problem won't be fixed immediately by the software team, we really script the bug. So we really implement the test case in that way that it verifies the bug. So the test case is passing again, and the cool thing is, if the bug is solved, the test case is failing again. So you are remembered, okay, there was a bug, this seems to be fixed now, you can verify, you can script the way, or you can comment in again the lines which should test the correct behavior, and the test case is passing again. So you have done the verification, everything is green again, everybody is happy. The whole test automation should be treated as a software project as well. So you should test your test automation, you should use the same practices you are using in a normal software test, in a normal software project. You should use version control, you should do peer reviews, as mentioned, you should test your test automation, etc. To be always green means also that you need an intensive recovery from a failure. So if there is a failure, the next test case might get a problem because this failure leaves the software you are testing in a certain state or even the environment. So you have to clean up carefully. Maybe you have to reinstall, you have to refresh the system. If you use virtual machines, you maybe recover the virtual machine, you have to at least restart the PC. Things like this is really important, that the test cases afterwards won't get any problems. And finally, you should have patience. You should have endurance, because it really takes a while to get the framework, to get all the scripts. Sometimes even one script takes a long time to get it stable and reproducible stable. So to analyze all these problems you might get in the test automation, you need a good debuggability. So you need a lot of logs. You should log everything you can think of. Maybe you should take videos, at least photos or screenshots of the tests you are doing. You should maybe create dumps of your test subjects. Everything which helps in the end to analyze the problem should be done. We also have implemented that we are rerunning failures. So if a test case is failing, we will rerun it on 2 different machines, again, to see if this problem is reproducible, or if it is maybe a dynamic problem, and next time it's passing again. So getting more data with rerunning the test case is also really, really helpful. So we call a failure only if all the 3 test runs are failing, then we really have a reproducible problem, and it's worth to create a ticket out of it, maybe. And do not forget to analyze your test runs. So if you rerun the whole test suite every night, but nobody is looking at the data and at the results, it's useless. So it's really hard work every morning. Our job is to rerun the whole test, to analyze the whole test suite.
Okay, after we have dealt with the defense of our team, let's take a look at our offense. And as in the soccer team, in test automation, the offense is the fun part. Our first offense player and offense midfielder is flexible and automatically triggered test runs. So what do we mean with flexible? At first, run test target oriented. We support different major versions of our system under test. We support different platforms like Windows XP, Windows 7 and so on. And we support different UI languages and run tests under different user access levels because our system under test needs authentication and authorization. Then define different test bundles and scopes. For example, a bundle called smoke tests that runs only the most critical tests. We use such bundle when a version has to be released contemporarily. Another bundle, the release test bundle, runs our entire test catalog, but only in one supported language that is randomly selected before each test case is started. This bundle is usually executed before each release of the new version. And our third bundle, called weekend tests, is a bundle that runs our entire test catalog too, but with all supported language and under all platforms. So running so many permutations needs much time, so this bundle is only executed, as the name implies, at the weekend. And finally, install an automatic trigger to encourage continuous integration and continuous deployment, continuous delivery. When a new release was built, the test run should start immediately. When a build was done in the evening, we can analyze results in the next morning. So, now let's take a look at our next offense midfielder, parallel execution. And parallel execution is important for reducing execution time of test runs. Real hardware should be used to test close to the reality. Virtual machines or Docker containers can be used to scale well. Tip: the count of virtual machines should depend on the test duration. Your most important test bundle can be executed in your required time frame. For example, our required time frame is one night. Using several machines, either real or virtual, encourages you to test easily all the platforms your system under test supports. But be careful when reusing machines. Tests should be atomic, so an accurate preparation and cleanup should be done before and after the test has been executed. So you have to distribute all the test resources and scripts to your target machine where the test is executed. This can be done easily via a source code management system like SVN or Git or so on.
Let's further attack. So diversion, what does diversion mean? So diversion means to randomize the execution of your test case. So all the time I hear test automation is nice, but we are not finding any new problems. We are not finding new bugs. So we still have to do manual testing. That's right, and I believe manual tests still have to be done next to test automation, like exploratory testing. But randomizing your test execution, like that the framework decides which way to go to a UI path, or which data to be used, or on what platform are we executing, with what language, etc., really helps to find new issues. And we have found a lot of new issues with high-level keywords, which are just standing there for a huge feature, and then the framework decides, okay, where to go, how to go there. So this is really helpful and really attacking, and the most fun part in the whole test automation from my point of view. Come on, yes. And the striker, promotion. So you have to promote yourself. You have to show your success. So you can be the best test automation engineer on the world. If you are working just in your cabinet for your own, you can maybe report a lot of bugs, but if nobody knows your success, your results, you might be kicked out of the match. So you have to get recognition and appreciation, and you have to get high-level support from the management. And if you create reports, frequent reports, which are easy to read, which are easy understandable, managers are even awaiting these reports and are really supporting you, and maybe you are able then to extend your test automation even in the end. So let's have an overview. Starting with the goalkeeper. So the goalkeeper really keeps your test automation maintainable, extendable, and understandable.
The defense keeps your test automation reliable and robust.
The midfield keeps everything executable, always up and running, and ensures that you're always ready to test.
The attacking midfield keeps your test automation effective and efficient.
And finally, the promotion keeps your test automation alive. So as in soccer, as I said, if the management doesn't trust you, they're exchanging players, or even they're exchanging the whole team.
So, when starting a soccer match, we should not only focus on ourselves, our own team, but also have to analyze our opponents. And as a software tester, everybody of you knows you have to deal with very strong opponents. It's not like playing against the Netherlands. It's like playing against Italy and Spain at the time sometimes. And as you can see in this picture here, it also often feels like playing against an opponent that don't play fair at all. One key player of our opponent is time. We as software tester have never enough time. A software tester's time resources are limited, and another reason is simply that we started too late in the project phase with setting up our test automation and started too late with testing. Don't start with testing and setting up the test automation with the first release candidate, do it already at the beginning of your project. Then we often try to take two big steps. Be patient, make small improvements, implement your test automation in small and reasonable iterations. Additionally, sometimes companies have missing business strategies, so that each project tries on its own and the test automation of several projects cannot benefit from each other. Management also often thinks that, yes, testing software is a no-brainer, and especially testing automatically is a no-brainer and can be done easily because everything is done automatically. So some of you bought some tools for test automation. Don't have too much confidence on these tools, even if you have paid much money for them. So none of these tools is a holy grail that fits to all your requirements to test automation in every detail. And ironically, they can contain bugs too. It's just software. And last but not least, another fantastic key player of our opponent is forgetting non-functional exploratory and usability testing, which are done usually manually. So don't focus only on test automation. There are cases where you have to do manual tests too.
Okay, our course of the match. So we have started with the test automation more than 6 years ago. And we have started to build up our team. In the beginning we thought about, okay, what do we need? We have planned all the resources, all the tools, but all the key players as well. So we have thought about, okay, where do we want to go? Then the first training. So we even haven't started the match. So the first training is something like, okay, let's play around with the tools, let's have something like a hello world, let's see if this can work at all. And then the kickoff. Okay, the direction is correct, the tools are okay, the plan is perfect, so let's have a small set of basic scripts. So, as done in Windows, this is always started with a calculator. So you choose some easy features in your product, start with them, get the test scripts up and running. Okay, we have started the match. The first half time was more or less, we are concentrating more or less on the framework. We are setting up all the keywords, all the abstraction layers. We have invited a lot of fancy things to get the keywords stable, etc. And we haven't been concentrating too much on the test scripts. The test scripts are just done to extend the framework during the first half. At the halftime, we got the first yields. So we played even half of the match to get some results. We had some scripts, and in the halftime we have established something like the automatically kickoff of the automation system. We have established something like an automatic release management, that we are collecting the release notes automatically, etc. So things like this to automate as much as possible, not only the test scripts. Then the second half time. Now it's time to concentrate on the test coverage. We have discovered new areas we have to test. We try to reach an acceptable coverage. So we have used all our requirements, all our use cases, user stories, but also old closed bug tickets to analyze, okay, where are the problems in the past, where are the risks of our product, what to automate, and then really at the end of the match, we reached an acceptable coverage with a lot of more automation on the left and the right, so like the release management, etc. And we have been happy. We thought, okay, we are done, that's cool. So, but unfortunately, we have to enter the extra time because there are sporadic problems. And still, after a couple of years, we still have sporadic problems. So sometimes a test case is failing, nobody knows why. So we are analyzing, we don't know what had happened there. We have a lot of logs, we have a lot of information, but still we are surprised, and it seems sometimes that God's hand is doing something like in the World Champion match. So, we don't know where is the problem, and still in the extra time, you are solving all these tiny problems, and we are still waiting for the end of the match. So still, there's a lot to do. We have still a lot of areas which are untested in the test automation. We have to maybe to do manual, or they are even untested at all. And after years, still a lot of work is to be done. So it's not just kicking off with a tool, running, and that's it. But we have improved all the time, step by step. We have done a lot of things. So most of the test runs are at least yellow. It means not any failure anymore, failing all the 3 times, just sporadic problems. And we are improving. We have promoted to another league, to a better league. And I believe we are now playing Champions League finally, because we have nearly 3,000 tests running every night. We have a long weekend test suite. So I believe it's really beneficial nowadays. So that's why we call this presentation Champions League Test Automation. And if you follow some of the best practices, some of the rules we have presented here, maybe in the end even you might be world champion, and you might also play in a very good league in the end. So thanks, that's it for today for us. Hope it was okay.
Thank you very much.
I cannot see anything.
I cannot see anybody.
That's here.
Oh, here's the lady.
Hello, thank you for your presentation. I wanted to ask you about the diversion tests.
Yeah.
How did you implement them, and are they not calling like problems with your tests as we use randomized data?
Yeah.
So that you are not able to verify something, for example, and what you do about that?
Of course, if you use randomized data, there are 2 possibilities. Fully randomized, so that you really don't know what has been entered into this field, and this can be used maybe to test that a login is not possible. So you use, okay, you have to enter a string to this field, and you should put anything, and the user should be unknown, and then you can use randomized data. Quite often, we are using different choices. So we know, okay, there are, for example, 3 different user levels for our application, and the test framework decides at runtime which user to choose this time to execute this test case, which language to use to execute this test case this time. So already the preparation for the test case is randomized, so it chooses a random user, a random language, a random OS, a lot of other random preconditions for this test case. And in the test case, we have high-level keywords to randomize, as I said, how to go to a dialog. For example, a dialog can be opened via shortcut, Control-O to open it. You can go to the menu, you can click the icon, you can maybe use a context menu, whatever. And we have randomized how to open it. So the test script decides at runtime, now I will use hotkey, or now I will use the icon. And we have really discovered different implementations how to go to the dialog. It shouldn't be the case, so you won't script 4 different test cases if you have 4 different UI passes. But if you randomize, you make sure that statistically every 4th test run, each of the passes is used. So, and then you might discover, hey, when I use the hotkey, it's not working. When I go via the menu, it's working. So something like this.
Okay, so who is the first then gives the question, that person gets the prize. So I encourage everybody to be the first. So do we have any more questions?
Let's see what present he has for the second question.
Yeah, for the second without prize. But with the answer.
Okay, so I would like to ask about green person. Is it any traceability of marked covered failing test cases?
The traceability, which test casing have been failing and have a workaround. Yeah. So what I maybe have missed to say is that we have of course, a traceability to the bugs. So if we put a workaround in the test script, we refer in the test script to a bug. Of course, you have to create a bug ticket because there was a bug. And in the bug, we trace back to the test case where the workaround is implemented. What we do not have is a statistics, how many workaround have we implemented? I think this is a question. If there is a traceability, how many workarounds are there? Maybe my assumption is maybe it's a minor bug. Maybe it's a spelling error or whatever. And this won't be fixed ever. And the management decided we can live with this bug. We maybe keep it open, we maybe close it, whatever. Then I don't care about the workaround because that's a real implementation. I don't want to track there are 20, 50, 100 workarounds. I don't care. So if this is implementation, if this is shipped to the customer, that's the functionality, that's how the product is working, and that's what we are testing. So that's a fact. And if somebody decides, maybe after 2 years, let's fix this spelling error, then the test script is failing. I have the traceability in both directions, from the test case to the bug, from the bug to the test case. I will fix it. I will put a note in the bug, test script updated, etc. So there we are. Everything is green again. So that's the main idea. So we are not tracking really how many workarounds are there. We have quite many. Yeah, I agree. But from my point of view, that's a fact. That's a functionality right now. So let's test it as it is. So.
So maybe we have more questions. Oh, I see a lady there.
Ladies are preferred. Sorry.
What would you advise for projects that already have a lot of functionality and no tests at all?
Yeah.
Like how to start?
I didn't mention, or we didn't mention it as well. So our project was 20 years old. It was 20 years sold already. And we had a few manual tests, but most of the tests are, okay, let's play around with the product and let's ship it to the customer. And a couple of years ago, we decided, okay, we should start with testing. This is a really critical product, a safety relevant product we have. So we have introduced test automation really with a mature, stable product. And as Manuel mentioned, take small steps, that's our advice. Don't try to test each and everything. Maybe select the most critical functionalities, select your key players, start small, and try to make small improvements step by step. And if there is an existing product, it takes a year to get all the work done, which should have been done maybe all the years before. So you cannot do it in a short time. So that's my advice. Do you have another?
I completely agree.
Sorry, Manuel should also maybe answer this.
Everything fine.
Okay, so we still have some time for the more questions.
1 year.
Yeah.
So as I understand, this is mostly UI testing, right?
Yeah.
So of course you probably also have like unit tests, integration tests, or something like that. Or is it? I mean, I just wanted to get an understanding of how do you synchronize between different kinds of tests, or do you have plans maybe to have some unified solution to which would test and would report this perfect test pyramid, you know, like you need to have most of the unit tests and integration tests, and then UI tests are only at the top. So do you have any ideas on that?
By clicking, I missed the testing pyramid. We have it on one slide, but somehow my remote control was not working perfectly. That's why I was somehow surprised at one slide, which was very short. We have the testing pyramid there, so you should have a lot of unit tests, maybe a couple of interface tests, and just a few GUI tests on the top. But as mentioned, our product was pretty old when they have been starting. Unit tests haven't been well known in the 18th and 19th. So we do not have, or our developer says, we have a few unit tests, something like 30, which is nothing with more than millions of code. So my point of view is we do not have any unit tests. And that's why we had to swap the pyramid. So we have just a few unit tests. We have just a few more, something like interface component tests. We have some, but also just a few. And unfortunately, we have to concentrate on the most, on the top layer, the GUI tests. That's why we have quite a lot of GUI tests, and that's why we have to put a lot of work in the GUI framework, etc. So I agree, but the only solution was put work to the GUI test, because if you have a very old product, 20 years old or even 25 years, you cannot reinvent all the unit tests. This is really impossible from my point of view. So you have to refactor a lot, etc. We are still trying to convincing the development team that they should, at least for new functionality, for new components, they should use unit tests. It's sometimes hard to convince them. So they always say, you have a very nice GUI test framework, you will do it. So that's unfortunately the fact.
Okay, and the last question before the lunch break.
Hi.
Hi.
So you are always green, right? And providing reports to your management, promoting yourselves, right?
Yeah.
I was wondering, what does your manager say when he or she see all the green reports?
Why are you testing? Because there are no problems.
Yeah,
right?
Good job. You
Yeah.
implemented all the workarounds for the
Exactly.
bugs.
And the developer never create any problems, etc. Fully agree. Good point. Really good point. But we, of course, also track how many bugs are discovered, how many problems are there. So be always green doesn't mean there are no problems. That's not the case. We have a lot of problems. We have to do a lot of work to get it green again. And we are reporting a lot of bugs. And that's part of the report, of course. So how many bugs have been discovered, how many problems are there, and we have a lot of metrics regarding all the bugs. We have open bugs, new bugs, etc. So this is an important part of the testing and of the report. So, and then the amount of test cases, of course, but also the statistics, how many pass, fail. And we are not always green. That's not true. So a test run, if it runs with a new software package, it has always some reds because there are new problems. Only the second run should be green again because you solve all the problems. So the first test run is always, nearly always red in the beginning. So, but to be then green again ensures that the next test run with a new candidate again highlights only the new problems. That's the point. So if you solve all the old problems and you retest a new software, the new test run only indicates new problems, and you are concentrating on the new problems and not on the big forest of old problems, and you try to pick up the new tree somewhere in the forest. That's really a hard job. So that's the point.
Okay, so the last question. So who is going to win the next World Cup?
We are from Germany, so easy
I
question.
thought the team of the
Not the
testers.
Netherlands.
I thought the team of the testers.
That's right.
Thank you for your presentation. And here's the present from organizers.
Thank you.
Yeah, thank you.
Thanks a lot. So if there are any more questions, we are still around. Maybe we are not wearing the triggers anymore because it's not really nice to wear it. But maybe you come to us and just have a discussion, have a chat with Art. So you are welcome. We are the whole day around. So we are glad.
Okay.